Here's how you solve this cubic equation. You can see straight away that x is a factor. So if we take x out, we've got this, and then you can see that x squared minus x minus 2 factorizes. X times x is x squared, 2 times 1 is 2, it's got to be minus 2x plus 1x. So therefore x equals 0, x equals 2, or x equals minus 1. And then you can substitute the values back into the original equation. You can put 2 into here, 8 minus 4 minus 4, that's 0. Try minus 1 in there, minus 1 minus 1 plus 2, that's 0, and then clearly 0 works as well. We can use that information to sketch the graph. So if we're asked to sketch the graph y equals x cubed minus x squared minus 2x, then we know that at 0, at 2 and at minus 1 the graph crosses the x-axis. Let's label that x and y. It's positive x cubed, so this value here is positive x cubed, so the graph generally goes like this. When x is a very large number, y is very large and positive. If this were minus x cubed, then it would be this shape. It would be the reflection in the x-axis, but it's not. So therefore, when we ask to sketch the graph, we can say that it goes through there and like that. This is how we solve this cubic equation. Because x is not a factor like it was in the last one, it's slightly harder. We're going to use the factor theorem. Often questions give you hints. A little bit of inspection of this equation will show you that x equals 1 is going to be one of the solutions. I can see that straight away because I can see that if I put 1 there, that's 2, 1 there, that's 1, 2 and 1 is 3, minus 1, minus 2, so x equals 1 is going to be one solution. So because of that, I know that x minus 1 is a factor. So now I need to work out what is it that I multiply by x minus 1 to make 2x cubed plus x squared minus x minus 2. So there's an x there, x times something here has got to make 2x cubed. So that has to be 2x squared. X times 2x squared is 2x cubed. But that gives minus 2x squared. Minus 1 times 2x squared is minus 2x squared. But I want it to be plus 1x squared. So I've got to, from here, I've got to be able to add on 3x squared. So that's going to be 3x. Let's just check that. Minus 1 times 2x squared is minus 2x squared. X times 3x is plus 3x squared. Minus 2x squared plus 3x squared gives plus 1x squared. Similarly for the next bit, I've got to get minus 1x. Minus 1 times 3x is minus 3x. But I want to have minus x. So I've got minus 3x, so this has got to give me plus 2x. So that's got to be plus 2. So minus 1 times 3x is minus 3x, and 2 times x is 2x. Minus 3x plus 2x is minus 1x. As a check, this last bit has to work, if not there's been a mistake somewhere. Minus 1 times 2 is minus 2. So now I know that x equals 1, well I knew that anyway, or I know that 2x squared plus 3x plus 2 equals 0. Try factorising, you'll see it doesn't factorise. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, 9 minus 4 times 2 times 2, well 4 times 2 times 2 is 16, 9 minus 16 is negative, so it's the square root of minus 7. There's no real solution. So there's no real solution to this, so therefore the only solution is x equals 1. This won't always happen, sometimes it does, like in this example, and sometimes this equation gets you two further solutions. If we're asked to sketch this graph, just squeeze this in here, I know that x equals 1 is one solution, that's x, there's y. I know that the graph doesn't cross the x-axis at any other point, it's a positive x cubed graph, so it generally does this, but it doesn't cross the x-axis here, so it just goes down like this. So when I'm asked to sketch this graph, I know it does that. This point here is minus 2. How do I know that? Because when I put naught there, naught there, naught there, the whole lot is minus 2. So that's minus 2. Need to be careful, I've just about managed it. I haven't checked yet whether this is a maximum point or not. When we do some more work on calculus, we'll be able to determine whether this is a maximum point or whether the graph, should I just do a little bit here, it may do that type of thing. There may not be a maximum point there. We need to differentiate and look at the second derivatives to see if that point there is actually a maximum point or not. The way I've drawn it as if it is. So that's it, that's factorising cubic equations.